Right. So is my screen is visible? Screen visible, Arkapa?
Yes, sir.
Okay, right, fine. So today in IC engine class, the module 10, right? So it is the last topic for our first unit. That is the introduction of the IC engines, right? So octane number, cetane number, and the ratings, and the materials for the IC engine components, right? So last class we saw what is fuels, the introduction about the fuels, and the classification of the fuels, and some how we can manufacture a fuels, right? And what are the process, the refinery process are involved in the production of the fuels that we can we saw in last class, right? Now we can recap what we discussed in last class, right? So first, the fuels, right? So what is the fuel, right? So we have to, right? So in the ice engines, the chemical energy has to convert into a thermal energy, and the thermal energy is converted into a mechanical output, right? That is called the heat engine, right? The chemical energy is converted into a thermal energy, and it will be converted into the mechanical output, right? So that's called the heat engine, right? So here the important one is the fuels, that is the chemical energy, right? So the fuels has to convert into a chemical energy, right? So at the fast manner the chemical reaction has to take place, right? At faster manner the chemical reaction has to take place, then only we can get a thermal energy in fast manner and the mechanical output also in fast manner, right? So the fuels are suitable for the fast chemical reaction, right? It's a mandatory one, right? So then the classification of the fuels, right? So the general classification, so whatever may be the fuels, it may have some hydrocarbon elements, right? So liquid, right? So fuels in the form of the liquid, and it contains the carbon and the hydrogen molecules, right? So depending upon that, the liquid hydrocarbons will be subdivided into many, that is the alkanes, paraffins, alkenes, and aromats. That like that we have subdivided into plenty, right? Then what about the alternative fuels, right? So the alternative fuels will be the alcohols or natural gases, LPG gases, and the hydrogen, right? So these are all in the category of the alternative fuels, and it is in the form of the liquid form, that is liquid hydrocarbon, right? So in this liquid hydrocarbon will be represented by C, N, and H, M, right? So these numbers, right? These numbers is important, right? So for the N value, for the gasoline is 1 to 4, and for the liquid is 5 to 15. But in IC engines, we can't use a solid fuels, right? We can't use the solid fuel, so we didn't see this one, right? So anyway, you have to know, right? For the solid fuels, the N value will be greater than 16, right? So in the liquid hydrocarbons, right? So first one is the paraffins or the alkynes, and the naphthalene, and the olefins, and the aromatics, right? So these are the liquid hydrocarbons, right? Liquid hydrocarbons, right? Then the other classification is the alternative fuels. That is, the first one is the alcohol. In this alcohol, it is include for ethanol, methanol, propanol, and butanol, right? So these includes in the alcohol categories. Then the gaseous fuels, that is LPG and CNG, that is compressed natural gases, right? LPG and CNG gases, and the manufacturing of the fuels, right? So whatever may be the fuels, all the fuels will be produced from the crude oil, right? So we have some refinery process, right? So due to the refinery process, we can get the plenty of products, right? So what are the distillation process? What is the cracking process? That is a thermal cracking, right? And alkylation, hydrogenation, and the polymerization. These are the refinery process, right? So due to this process, we can get a different type of products, right? Different type of products, right? So these are the products, right? These are the products. It is depending upon the boiling temperature, right? So the crude oil boiling temperature, right? So every stage we can get a useful product. Every temperature we can get a useful product, right? Then the properties, right? So last class we see only one property, right? So what is the relative density, right? So what is the relative density? Generally, the density means in a particular unit volume, how much mass is there. That is called the density. But in the relative density, it's a ratio between the densities, right? So we can compare the density of the fluid, density of the fuel to the standard one, right? So generally, what is the specific gravity? Specific gravity is the ratio between the densities, right? So density of the fuel or density of the fluid, either gas or a liquid, right? So the density of the particular working substance by the density of the standard. For the density of standard is water, right? So for the water, we can take a density is 1000 kg per meter cube, and it is for the temperature of 4 degrees Celsius, right? So this we can see in the sorry we can saw in the last class, right? So see here the density will be 700 to 800 kg per meter cube for the gasolines, right? For the gasolines, and for the diesels it's around 830 to 950 kg per meter cube, right? So the relative density measurement will be taken at this condition, right? The temperature is around 20 degrees Celsius and the pressure will be the atmospheric pressure, that is 101.3 kilopascal. Then the relative density for the gasoline is around 0.72 to 0.78, which is equivalent to the API standards, that is the American Petroleum Institute. The range will be 65 to 50, right? So up to this we can we discussed in last class, right? So in this class we can see the remaining properties, right? The remaining properties are the specifications, right? So for the fuel composition, right? So any fuel, whatever may be the fluid, it is not a pure one. It's not a pure one, right? So it is a mixture of all the elements or mixture of all the allying terms, right? So for the fuels, right? So whatever may be the fuel, surely we can have a hydrocarbons, right? So carbon content and the hydrogen content, right? So the carbon content for the aromatics is around 89%, right? The carbon content of the aromatics is around 89%, and the same carbon content for the paraffins or naphthalene. Paraffins or naphthalene are it's around 86%. When the benzene, right? It's a toxic one, right? It's a highly toxic material, right? So the maximum allowable is very important, right? So for you, for the considering of the benzene, it's a toxic material. So the maximum allowable concentration is very important. Its level will be 5%. Its level will be the 5%. Then all the fuels will have some sulfur content, right? So the sulfur content creates emissions more, right? The sulfur content creates the emissions more, and in the hydrocarbon, the sulfur content will be in the form of free sulfur or hydrogen sulfate or other some sulfur compounds, right? So it is uh, uh, it will create the corrode. It will create a corrosion in the elements, in the equipments, in the parts, right? So it is a corrosive element which corrode the pipelines, the fuel lines, carburetor, and the injection pump, right? For the diesel engine, the injection pump will be using, and for the yeah, petrol engine, we are using the carburetor and the supply of the fuel from the tank to the engine, right? So these three will be corroded by the content of the sulfur, right? By the content of the sulfur, right? So here the sulfur, right? It has a low ignition point and it promotes the knock. It promotes the knocks in the SI engine. It approximately 250 parts per million. 250 parts per million, and some gum deposits, right? So for the gasolines, the unsaturated hydrocarbons forms the gum in the engine. That is a paraffin, wax, naphthalene, right? So water maybe it may create some the formation of the gum, right? So it causes the operating difficulties. That is the stickiness in the valve and the piston rings and the cylinder bores, right? So it will have some difficulties in the operating conditions, right? So what is that stickiness values in the valves, piston rings, and deposited in the inlet and the exhaust manifolds, right? Then the water, right? So surely the water also, the water content, right? The water vapors also there in the fuel, right? So it is in the form of two. Right? It's one is the dissolved water and the free water, right? So these two present in a gasoline. These two present in a gasoline. For the free water, it is undesirable because it can freeze and it causes some problems, right? But the dissolved waters usually unavoidable during the manufacture, right? So we can control the free water, but dissolved waters we can't control, right? Then the lead, right? So for the leaded petrol, leaded gasoline or unleaded gasoline, the maximum lead content is specified, right? So lead causes the pollution and it destroys the emission control equipment, that is the catalytic converter in the exhaust system, right? Then the manganese is used for the anti-knock gasolines, right? So it's a maximum amount is specified as this much in a liter, right? This much grams per million in the liters. Then oxygenates is a compound such as the alcohols are used in gasolines to improve the octane rating, right? Improve the octane rating. So gas oxygenates are there in the fuel composition, right? So once again we remember. So what are the fuel composition? That is the hydrocarbons are there, benzene, sulfur content is there, and water content, lead, manganese, and some gum deposits and the oxygenates, right? So these are the specifications in the fuel composition or a fuel property, right? So the next fuel specification or a property is the specific heating value, right? So the specific heating value which is represented by the HU, right? It is represented by the HU, right? So it is the energy content of the fuel per unit mass, right? Its units will be the kilojoule per kilogram or the energy kilocalorie by the kilogram, right? So for the gasoline fuels, the specific heat value, right? The specific heat value is given in the term of the energy per unit volume, right? So here see unit mass, but here in the gasolines we are specifying the unit volume, right? So the unit, the instead of the kg we are using the liter, instead of kg we are using the liters or meter cube or see, right? Yeah, right. So in the IC engines, the lowering the heat values, lowering the specific heat value given the composition products contain the water vapor formations, right? So it contains water in vapor formation for the gasolines and the diesel fuels, right? So the 42,000 to 44,000 it is for the gasoline and it is for the diesel, right? So for the diesel, the specific heat value will be less while comparing to the gasoline values, right? So the heating value for the combustible air mixture, right, air fuel mixture, a decisive factor for the engine performance. Then what is flash point, right? It is the lowest temperature, right? It is the lowest temperature when the fuel vapor starts to ignite, when we are giving some heat or in contact with a flame or the ignition source, right? So flash point is the lowest temperature when the fuel vapors, right? The fuel vapor starts to burn or starts to ignite, right? So that point, right, that temperature is called as the flash point temperature, right? So for the gasoline it's may around 25 degrees celsius, and for the diesel it may around 35 degrees celsius. For heavier diesels it may have a 65 degrees celsius. Then another one is the viscosity, right? Viscosity is an important parameter for the combustion ignition engine, that is CI engines, right? So it influences the fuel metering the orifice, since the Reynolds number is the inverse function of the fuel viscosity. Lower the viscosity, so you can get a smaller diameter of the droplets in the spray. You can get a smaller diameter of the droplets in the spray, right? So depending upon the temperature, right, the viscosity may varies, right? So the low viscosity increases the leakage of the fuel system, right? The low viscosity increases the leaks in the fuel system, right? So it is a strongly function of the temperature. Depending upon the temperature, surely the viscosity may varies, right? So for up to for the 50 degrees Celsius, its viscosity will be 1.5 to 5 angular or 0.5 to 0.6 centistroke. That is the kinematic viscosity. We have a dynamic viscosity and kinematic viscosity. Here the kinematic viscosity will be 0.5 to 0.6 centistrokes. Then the surface tension, right? So when the fuel in the fuel line, it will be sprayed, right? So while spraying, the fuel will be converted into a small droplets, right? This droplet formation due to the surface tension, right? So due to the surface tension parameter, it affects the formation of the fuel droplets in the sprays, right? So increasing the surface tension will reduces the mass flow rate and the air fuel mixture in the gasoline engines. The lower value will create a smaller diameter of the droplets, right? So for the gasoline, it's may around 0.19 to 0.23 Newton per meter, and for the diesel engines, diesel fuels, it may around 0. Right, 0.0232 to 0.032, right, which is represented by the rho, which is represented by the rho. And one more is the freezing point, right? It is the precipitation of the paraffin crystals in the winter, right? So can lead a clogged filter, right? So it can be prevented by either the removing the paraffins from the fuel or adding the flow improvers, that is the additives, right? So antifreezing the properties are determined by the filterability, right? For the gasoline, the freezing point is minus 65 degrees Celsius, and for the diesel, it's minus 10 degree Celsius, right? So these are the important properties, right? These are the important properties for the fuels which may used for the IC engines, right? So what are the properties? The relative density and the fuel composition, and for the flash point, viscosity, surface tension, and the freezing points, right? So these are the important fuel specifications or fuel properties. Is it clear? Okay, right, fine. So next we can see uh, the octane and the cetane number, right? What is that octane number and what is that cetane number, right? So it is a measure, right? It is the measure of tendency of the fuel to the ignite, to the ignition spontaneously, right? So it is the measure, right? See, So octane number and Cetane number is a measure for the tendency of the fuel to ignite spontaneously, right? So generally the Cetane number will be represented for the diesel engines, that is the diesel fuels, and for the octane number for the gasoline, right? Octane number for the gasolines, right? So we can see, right? So what is Cetane number and what is octane number, right? So before going to see this, right? So we have to see what is gasoline velocity, right? Gasoline velocity, right? Then what is anti-knock quality of the gasolines? What is anti-knock quality of the gasolines? Okay, right. So knock occurs when the unburned gases ahead of the flame front. That is the end of the gases. That is the end of the gases. The knock occurs when the unburned gases, right, spontaneously. The ignite causing a sudden rise in the temperature is accompanied by the characteristics of the pinging sound, right? So most of them you heard the sound in the two wheelers also, right? The pinging sound, right? The ignite causing sudden rise of the pressures, right? Sudden rise of the pressure inside the cylinder, right? So this results the loss of power, and it can damage the engine too, right? It can damage the engine too, right? So the combustion chamber shape, spark plug locations, and the ignition timing, end gas temperatures, in inside the cylinder gas motions, and air fuel ratio of the mixtures, and the fuel specifications. These are the effects, right? These are effects for occurring the knocks, right? So what are the combustion chamber shape, the spark plug allocation, that is a location, ignition timings, N gas, that is the exhaust temperatures, and the gas motions, air fuel ratios, and the some fuel properties, right? So these are the effects occurring in the knock, right? So the compression ratio of the engine is also strongly affect the knocks, right? So the higher value of the compression ratio is better in the thermal efficiency, right? It will be discussed in airless class 2, right? So the compression ratio, right? So when the compression ratio increases, automatically the thermal efficiency is increases, right? But it it will create the greater tendency of the knock, right? It will occur the greater tendency for the knock, right? So for the critical compression ratio, when the knock starts, so the fuels octane quantity is required, right? So the higher fuel octane quantity is required for the critical combustion ratio, right? So the auto ignition of the end gases, that is the exhaust gases, causes a rapidly increase of the pressure inside the cylinder, right? So this pressure waves which renovate the combustion chamber at the frequency of 5000 to 8000 hertz, right? So depending upon the geometry of the combustion chamber, right? So due to this, the antenna quality may be measures, right? So the antenna qualities is called as the octane number and the cetane number, right? The octane number and the cetane number, right? So here you can see the ROM number, that is the research octane number, and for the motor octane number for the different fuels, right? So here see, it is the both are octane numbers and the cetane numbers and the cetane number, right? So generally the cetane numbers for the diesel engines, right? Then the boiling point of the fuels, then the cetane number, right? So the cetane number is used to specify the ignition quality of the diesel fuels, right? So running on the low cetane numbers will produce the cold start problems, right? The running of the low cetane numbers, right? The low cetane number will produce the cold start problems, the peak cylinder pressures, the combustion noise, and the hydrocarbon emissions increases will be increases. For the more fuel will be injected before the ignition, the less time for the combustion. The higher cetane number results the sooner ignition, that is a faster ignition, right? Extremely high cetane number may ignite before the adequate fuel and air mixing takes place. In the higher emissions, the power output can be reduced if the burning starts too early, right? So these are the conditions, right? So it improves the cold starting, it improves the high combustion, and it reduces the noise and white smoke and the hydrocarbons and the carbon monoxide and the particulates of the emissions. Then see, the higher octane is a premium fuels and the lower octane number is a normal fuels, right? So when the octane number increases, the anti-knock will be high, right? So here see the octane number is 93, but here you can get the high knock, but here the low knock, right? So it is the measurement of the fuel abilities to resist the ignition, caused by the pressure and the temperature, right? So the octane number gives the anti-knock values in the gasolines, that is the petrol, right? Gasoline fuels. Then the cetane ratings, right, indicates the cold starting ability of the diesel engines, right? So most automakers recommended the cetane numbers around 45, right? For the diesel engines, we already told, right? What is the value of cetane number? It's around 45 to 55, in the range of 45 to 55, right? So most of the scientists they recommended the cetane number for the diesel fuel is around 45, right? Its rating will be the 45, right? So what will happen if the cetane number will increases? The ignition time is too early, right? The ignition, that is the fast burning, by increasing the cetane value, and it is reversed, right? It is inverse for the octane rating. If the octane number increases, so the burning time will be gets slower, right? The burning time will be gets slower, and it may get high knock, right? And it may get high knock, right? So the ignition characteristics of the fuel affects the ignition delay, right? So the ignition quality of the fuel is defined by the cetane numbers, right? So for the low cetane numbers, it is for the low speed diesel engines, that is its values around 25 to 45, but the scientists will be recommended the cetane number of 45 for the diesel engine, right? So it is for the low cetane number, and it is for low speed diesel engines. Then for the high cetane numbers, that is the 50 to 60, it is for high cetane values, and it is for high speed diesel engines. But the diesel engines is normally in the range of 40 to 55 or 45 to 55. That's the range, right? That is the range for normal diesel. For the low diesel engines, its value will be 25 to 45, and for the normal 40 to 55, and the high it will be 50 to 60, right? So for the diesel engine, it gives the 50, it's around normal, right? It's around for the normal up to the value, right? So the results inadequate the cetane numbers, right? Inadequate of the cetane numbers. So what are the causes? What are the problems will be there? The poor ignition quality and the long ignition delays and the abnormal combustions, abnormally high combustion pressures, right? The sudden pressures, the pinging sounds, right? And the potential uneven thrust on the piston or a cylinder, and the louder engine noise, right? And louder engine knock, and the excessive engine knock and small at the cold start, smoke at the cold start, right? So these are the octane rating and the cetane rating, right? Then the last topic of our syllabus in the first unit is the materials, right? The materials for the IC engine components, right? So for the IC engine component, the main component is the cylinder head, right? So the its function will be it guides the piston, right? It guides the piston inside the cylinder, right? That is called the cylinder head, right? Generally, the cylinder head is made up of the gray cast iron, right? It is for the gray cast iron, right? So why we are using the gray cast iron means uh, it properties, right? Wear and corrosion properties is good, right? So we are using the gray cast iron and some aluminum alloys, and aluminum alloy means aluminum and silicon for the better casting properties, better casing properties, right? So uh, what are maybe the cast iron materials will be used for the engine components, right? Most of the engine components will be made up of the cast iron. So we can see the what are the advantages of the cast iron, right? It is good for the casting materials and high machinability, and it does not wrap under the high temperatures, and the pressures will be developed in the cylinders, will be developed in the cylinders. So the porous, right? It is slightly porous in the nature, so it can give some better lubrication films, right? It can retains a better lubricating between lubricating in the cylinder walls, and it will not wear, right? It does not wear too much, right? The wearing characteristics is good, and the corrosion characteristics also good, and the damping characteristics, that is for the vibration characteristics, right? The vibration characteristics is good, and the low value of the coefficient of thermal expansion, so it will not expand at high temperatures, right? Then it will be relatively cheap while comparing to the other materials, right? So it is for the good machinability, and it do not wrap, right? Do not wrap at a high temperature, that is it do not uh, distortion, it do not distort at high temperatures, and the pressures developed in the cylinders, and it's slightly porous in nature, so the lubrication will be somewhat good, right? The lubrication film will be good, and it will not wear. So we are using good damping characteristics, that is the vibration arresting characteristics, and the low thermal expansions, right? So the low value of the thermal expansions, and it will be cheap, right? So because of these reasons, the most of the engine components will be made up of the cast iron material, right? Then the important component of the engine is the piston, right? So it will transmit the power, right? It will transmit the power or force, right? In the exhaust stroke, sorry, expansion stroke to the crank shaft, right? It will transmit the power, it will transmit the force, right? Right. So it is guiding. It serves as a uh, guiding and bearing for the small end of the connecting rods, right? It is made up of same, see, the cast iron and the aluminum alloy. Here the aluminum alloy is the aluminum and the silicon composition, aluminum and the silicon composition, right? So why we are using the aluminum means aluminum alloy, generally the aluminum will be a low weight material, right? So it is lighter than the cast iron, right? So for the aluminum alloys, it is lighter than the cast iron, and it will have a higher thermal conductivity, right? It will have a higher conductivity, and it is also having some disadvantages also. Why? Because the aluminum is having a low weight, right? It is lighter, so the strength also reduces. Strength also reduces. Then the piston rings, right? So what is the piston rings mean? It will prevent the leakage of the gases into the crankcase, and it will prevent the lubricating oil. It will splash. It will takes the lubrication oil to the cylinders. Right. So the piston ring is also made up of the cast iron. Right. So cast iron, the fine grained materials, and the high elastic materials. Right. So it is also made up of the cast iron. Then sometimes it may be made up of the alloy spring materials also. Why? Because why we are using the spring steels means we have to get a high elastic property also here, right? Then the connecting rods will be made up of forged steel or duralium or a malleable cast iron, spheroidal graphite cast iron. Then the crankshaft, it is forged steel or a spheroidal graphite cast iron or nickel alloys, right? Then the crankcase also a pressed sheet steels and the aluminum alloys for the high thermal conductivities. And the inlet and exhaust manifold, right? It is made up of the aluminum alloy. And the camshaft, right? So camshaft is usually made up of the cast iron and the addition of the chromium. So the wear, right? So the corrosion and the wear properties will be good, right? So it will not corrode easily, right? So once the cam will be corroded, what will happen? The timing will be changes. So it will not corrode, right? It will not corrode and it will not wear in faster manner, right? So the cast iron with addition of the chromium will be used, right? So the wearing property and the corrosion property will be good here, right? So it will not corrode and it will not wear. So the timing is very important for the camshaft. Then the flywheel, it is the crank rotation to the uniform uh, speed, right? It is also made up of the cast iron. It is also made up of the cast iron, right? So up to this we can complete unit 1, right? Up to this we can complete the unit 1.